Here we're talking lost signs. Lost signs is going to be a formula that we use when we're trying to solve triangles that aren't right triangles. You know, you've got sine, cosine, tangent, and all the trig functions with right triangles. Well, what happens because not everything's a right triangle? We'll get lost signs. Now, the formula for the lost signs is going to be derived from an area formula for a triangle. Remember, area formula is 1/2 base times height. Well, if it's not a right triangle like triangle ABC, we put the height in there, and you've seen this many times. Height and the base are perpendicular to each other. We got that number, and we do all that fun stuff. But if we use trig to help us out here, because a right triangle is formed, finding h can be derived from taking the sine of angle A, which is equal to opposite over hypotenuse in this little triangle, h over c. So the height is simply taking c, the hypotenuse of this little right triangle, or this side, times the sine of angle A. Now, can these b's and c's be switched around? They can. You'll see here in the future what I'm talking about. So we'll take 1/2 times b, the base, times c times the sine of angle A. So our area formula, if it's not a right triangle, 1/2 BC times the sine of A. Or in other words, see here, BC, the included angle. There's three options depending on how it's labeled, depending on what you have. So it's not like, oh, I can't do this all these different ways. There's the first one we have. We could go 1/2 AC. So there's A and C. So the included angle would be B times the sine of B. Or, again, depending on what's labeled, 1/2 AB times the sine of A. So AB, I said A, sorry, sine of C. So we have that. So three new formulas that we can use in any triangle to figure out area. So let's look here. And obviously, if it's a right triangle, we're going to be using trig function because, again, it's about ease and about experience using stuff. So triangle ABC, we're going to try to find the area to the nearest tenth. So here's what we have. Side, side, included angle. However you want to look at this. Okay, I got A and B here. So it looks like this. I mean, all these things can be rearranged, if you will. But look what it says, no matter how they're labeled. Side, side, and the sine of the included angle. So I'm going to set this up. 1/2 times 8 times 9 times the sine of the included angle times sine of 104. Take that handy dandy calculator out. So we're going to get 36 right here. So we got 36 times the sine of 104. I always like to close the parentheses. So roughly 34.9. Labeling counts centimeters squared. So from here, area, non-right triangles, we get our lost signs formula derived. And it comes out as a ratio, and by setting the three area formulas that we just had equal to each other and simplifying the proportion, we get this. The sine of angle A over the side opposite, sine of angle B over the side opposite, sine of angle C over the side opposite. So we can use this ratio to find things out. Now, a little bit of a rule of thumb. You want to use exact answers as many times as you can. What's that mean? So when I say exact answers, those would be the things that are given to us or things that come out without rounding. So in this triangle, we have two angles given to us and a side. Two angles and a side. So solve the right triangle. Find all the rest of the missing pieces. That means I got to find an angle, and that means we got to find two sides. So 80 degrees was given to us, 45 degrees was given to us. So we right now have 125 degrees in our triangle. So we're going to have a 55 degree angle right there. So there's one. So angle A, 55 degrees. Now we got to find the rest. Now, as we look at these angles are all considered exact. This is considered exact because it was given information. So let's figure out what we want to find. I'll go alphabetical order. I'm going to find A. So I'm going to take the sine of 55 over lowercase a equals, I can use B, I can use C. Well, let's look. I don't have both parts of this ratio. I got the angle, but I don't get the side. I do have both parts of this, so this would be kind of what I use throughout the problem in this particular example. So I'll go sine of 80 over 3. Well, through the magic of proportions, I'm going to not round anything. I'm going to set this thing up so I can have exactness. So we got the calculators. Let's might as well be as precise as possible. So we're going to cross multiply to do this, but then we're going to have to divide. So for those of you that aren't seeing where I'm at, I got A sine of 80 equals 3 times the sine of 55. But I need to solve for A. So 3 times the sine of 55 divided by the sine of 80. So let's go here. We're around. Oh, I'd already said it here. Round the nearest tenth if needed. So we're going to take 3 times the sine of 80, sine of 55. I'm going to close that, get that answer. And I'm going to divide that by the sine of 80. Close that, answer. So approximately 2.5. units. I don't really have anything set up for that. Okay. And now, so that's a rounded answer. I really don't use that in my future calculations. So now we got to find what? B. So sine of angle B, 45. Some of these things you're going to start memorizing and know. So that'll be cool. Over B. I'm going back to the sine of C because of the exactness of everything. So sine of 80 over 3. As I do my work, same thing's going to happen. I'm going to get cross products going on. B sine of 80. 3 sine of 45. So B will be the exact answer of 3 times the sine of 45 divided by the sine of 80. Calculate away. So as we plug away, 3 times the sine of 45, got my answer, and we're going to divide that by the sine of 80 again. Boom. So B, approximately 2.2. There's your law of sines, using ratios.